Hello, and welcome to the Math 120 Final Exam Review, Logarithms. My name is Tuesday J. Johnson. I'm a lecturer at the University of Texas, El Paso, and an assistant professor at Doña Ana Community College. This Math 120 Final Exam Review is for Doña Ana Community College. We have our reviews posted. You can find them online at dacc.nmsu.edu/math. On the right side menu, you'll find Final Reviews. Click there, and it'll take you to the list of all of our final reviews. And you can find this 10-page document there, Math 120 Final Exam Review. The problems that I'm doing here come straight from that review. Here we go. As you're doing the exam, there's going to be two types of problems. There's going to be some problems that are no calculator, as indicated by this. Or there will be some problems where you get to use the calculator. If there's nothing there, like I don't have to cross out of a calculator, then you can use the calculator. It's all good. The no calculator problems, for the most part, the numbers are fantastic. The numbers work out really well. You don't have to do 3/7 and approximate it to 4 decimal places or anything like that. They're nice numbers. Let's do some examples. We're going to let g of x be log base 6 of x. I want to find g of 36. Now I'm putting 36 inside for x, right? So log base 6 of 36. Log is just a power. So that says, what power do I put on 6 in order to get 36? 6 to what power is 36? 6 to the second power. Since the exponent is 2, 6 squared equals 36, the log equals 2. To find g of 6, log base 6 of 6, I'm asking, what power do I put on 6 in order to get 6? Well, 6 to the first power is 6, so the logarithm equals 1. First power, 1. But we're not just going to kind of go here and there and whatever. Now we have to pay attention to notation. G of x is log base 6 of x. I want to know what is g inverse of 0. Pay attention to the inverse. What is the inverse? Our inverse function is g inverse of x, 6 to the x. Right? Because the inverse of any logarithmic function is the exponential function of the same base. So, g inverse of 0, I'm going to put 0 in for x. 6 to the 0 power, that's 1. G inverse of negative 1. Again, the inverse is an exponential function. So I'm going to put a negative 1 as an exponent on 6. 6 to the negative 1 is 1/6. Write it down. Ask yourselves. Remember, a log is just a power. So log base 6, let me write this first one down. Log base 6 of 36, I'm asking myself, what power do I put on 6 in order to get 36? And that's how I got the answer of 2. 2 is the power that I put on 6 to get 36, so the logarithm is equal to 2. We're going to solve some equations. You don't need a calculator, I promise. Log base 4 of x equals 1/2. If you have your variable inside the argument of the logarithm, the easiest way to solve is to rewrite in exponential form. The base of the log is 4, so the base of the exponential is 4. The log equals the exponent, so the 1/2 is the exponent. So 1/2 is the power to which I raise 4 in order to get x. So 4 to the 1/2 equals x. Remember, the 1/2 power is a square root. Right? The denominator of a rational exponent is the index of a radical. Square root of 4 is 2, so x must be 2. Log base 2 of x equals negative 1. Negative 1 is the power I put on 2, so 2 to the negative 1, in order to get x. 2 to the negative 1 gives me 1/2. In part C, log of x equals 6. Notice there's no base written. Anytime there's no base written, it's assumed to be a common log. That's just our notation. Just like square root of whatever, we don't write a 2 in the index usually, but we have to with cube root, fourth root, and so on. common log is used so frequently, it's our go-to default. If you don't write a base, it's assumed to be a 10. So 6 is the power, because all a log is a power, that I put on 10. 6 is the power I put on 10 to get x. 10 to the 6th is a 1, followed by 6 zeros. That's 1 million. Number 15, part A. This was in 3 parts. I put each one in a different video here. Find the inverse of f of x equals log of x. The inverse of a logarithmic function is the exponential function of the same base. But as I said in 14c, with no base written, it's the common logarithm, so the base is 10. So if f of x is log of x, the inverse is 10 to the x. Don't overthink it. There's no work to be shown. Good job. Now we're going to do 3 problems. Write the following as a single logarithm with a coefficient of 1. This is key for me. Single logarithm, meaning in your answer you're going to have one L, one O, and one G. You're not going to have multiple logs written down. You're not going to draw any pictures of trees that have been cut up into logs. You're going to have one L, one O, one G. It's a guiding principle to let you know when you're finished. So, if I want to write as a single logarithm, as I'm condensing, I always start with the power rule. The power rule says that our coefficients here, this 3 will come up as an exponent, and my 2 will come as an exponent. Kind of went crazy on that one. So I'll have log of x to the 4th cubed minus log of 3x squared. Now it's not the whole log of x to the 4th that's being cubed. I'm not multiplying log times log. I'm multiplying x to the 4th by itself 3 times. Okay, very important. So I have a log. I'm going to simplify. X to the 4th to the 3rd. If I have a power raised to a power, I multiply. This will be log of x to the 12th. Minus log of 3x all squared. 3x times 3x, or 3 squared is 9, x squared. Once I simplify, now I have log of one thing minus log of another. I'll use the quotient rule to write these as a single log. Subtraction gives me division in the argument. So the log of x to the 12th over 9x squared. And again, I'm going to finish by simplifying. X to the 12th, I take out 2 of those. I'm left with x to the 10th in the numerator. And my coefficient of 9 stays in the denominator. Completely simplified. My answer has a single L, a single O, a single G. I'm good to go. Write the following as a single logarithm with a coefficient of 1. 2 log of 2x squared plus 3 log of 2x to the 6th. Alright, so we use the power rule first. This 2 comes up as an exponent. My coefficient of 3 comes up as an exponent, as I have indicated. I'm going to simplify. The log of 2x squared all squared. So 2x squared times 2x squared. 2 times 2 is 4. X squared times x squared is x to the 4th. Plus sign. The log. Now I'll have 2 to the 3rd power, which is 8. X to the 6th to the 3rd. A power raised to a power, you multiply. 6 times 3 is 18. So that's 8x to the 18th. This is the property of exponent distribution over multiplication, I believe is the long term for it. If you're multiplying 2 things raised to a power, you could raise each one to the power individually in order to simplify. Now that I have my arguments of the log, that's the inside part of the log, simplified, my addition turns into multiplication. And so I just straight up write it. It's log of 4x to the 4th times 8x to the 18th. It's not log times log, it's log of, and I only multiply the insides. And so I'm going to do that. I'm going to simplify. 4 times 8 is 32. X to the 4th times x to the 18th. Multiplying 2 things with the same base, you add their exponents. 18 plus 4 gives us x to the 22nd power. Yeah, these simplify steps, very important. I like to keep it clean as I go through, or else I get totally lost on what exponent goes where. Last problem of this type, and based on the order I'm recording this, last problem of all of them. Here we go. The natural log of 5x cubed plus 2 natural log of x plus 2 natural log of 3z minus 4 natural log of yz. This first term does not have a coefficient, so I'm just going to leave it as it is. The 2 coefficient becomes an exponent on my x. The 2 as a coefficient becomes an exponent on my 3z. And the 4 as a coefficient becomes an exponent on my yz. Let's simplify. The natural log of 5x cubed, nothing to simplify. The natural log of x all squared, I'm going to call that the natural log of x squared. The natural log of 3z squared, 3 squared is 9, z squared, minus yz to the 4th, that's y to the 4th, z to the 4th. Reminds me of a Yamaha motorcycle I used to have. Minus natural log of y to the 4th, z to the 4th. Here we go, staying on task here. Now when I simplify, I'm going to take 2 at a time. I'll take these 2 first. And when I combine these 2, I get the natural log of 5x cubed times x squared. Because if I'm adding logarithms, I'll multiply in their argument. Notice I didn't do anything with these 2, I just wrote them down. I should simplify that right now, but for some reason I chose not to. I don't know, on the last slide I said I always do. It's a good idea, and now I choose not to, but I'm going to go with it. Let's get a little underline here. Now I'm going to combine these 2 to give me this. All right? When I have the addition again, I'll have the natural log of 5x cubed times x squared times 9z squared, because the addition turns into a multiplication of the arguments. When I am finished with that, let's see if yellow works out for me. These 2 will now give me my quotient, because subtraction turns into division. So everything here is being multiplied together, and finally we divide by y to the 4th, z to the 4th. And it's at this step that I choose to simplify, because you can. Right? The last slide I simplified along the way. This one I didn't. Find the method that works for you, because they're both completely correct. It's what you can keep track of. It's what works best for you, not what works best necessarily for your professor or teacher if you're in high school watching this video. Good on you. Alright, so I'll have 5 times 9. My only numbers in the numerator. 5 times 9 is 45. I have x cubed and x squared. Those are the only x's. Multiply 2 things with the same base. I'll add their exponents, x to the 5th. I have a z squared in the numerator, a z to the 4th in the denominator. So there's 2 more in the denominator. I'll be left with z squared in the denominator. A y to the 4th in my denominator. There we go. We're finished. That's it. That's how you write as a single logarithm. We simplify, we combine, power rules. You're going to do all right on this exam, I promise. Whether you're my student or not, just deep breath, relax. Maybe bring a couple of mints, bring some gum. If you keep your mouth busy, it helps you focus more. Do great. Be great. Thanks for listening.